Hi, and welcome back to another Sourcegraph training video. In this video, we will dive deeper into how Cody works and how to get Cody configured. This will include an overview of the code graph, what it is, and how it's created, how Cody leverages it, as well as other topics like Cody's dependencies and services that it uses, data security and privacy, and current limitations. If you're unfamiliar with Cody, I suggest starting with the Cody overview video to understand what Cody is and how it works. It's also important to note that Cody is currently in beta, so the things that are discussed in this video are subject to change and may differ from the final product. Before we dive into actually configuring Cody, we should first quickly go over how Cody works and how it generates context. The code graph is what powers Cody, and it's really what sets it apart from other AI coding assistants. The code graph is a collection of data about your code. So all of your repositories, files, git commit history, metadata, etc., that's all indexed and stored on a Sourcegraph instance. Cody can then connect to that Sourcegraph instance and access that data to generate context and an understanding of a code base. It can use that to find relevant code snippets and the files it needs to generate context. It then packages that all up into a context window, which is then sent off to an LLM provider for processing. And then the resulting output is returned to the user. There are a number of different data sources that make up the code graph. That's first and foremost, again, all of the code from your code base, all of your files and repositories from across all of your code hosts that are then indexed on your Sourcegraph instance. There's a people graph through an understanding of indexed code owners files as well as inferred ownership. There's additional data from other sources that aren't just from the code host, so things like documentation or logs, security scanners, and more. There's precise compiler accurate code navigation as well. So an ability to understand your code at a semantic level. And last but not least, there are embeddings, which allows Cody to understand the right context to answer questions and generate code. So you'll notice a few of these have work in progress icons next to them. And again, Cody's in beta, so some of these are still under development. So today, Cody's data sources come from its ability to leverage Sourcegraph's universal code search and run a keyword search across the code base, as well as the ability to index repositories and create embeddings or a vectors database for each repository that Cody can access as well. So we'll dive deeper into both of those components, search and embeddings. A keyword search is the default method for Cody to generate context. It is used as a fallback when embeddings have not been generated for a repository. So when a user asks Cody a question or has Cody generate some code, Cody will utilize Sourcegraph's universal code search to run a keyword search across the code base, looking for relevant repos and files to help it generate the context it needs to process the user's request. Now, keyword search is the traditional approach to text search. It splits content into terms and builds a mapping from terms to documents. When a query is run, it extracts terms from the query and uses the mapping to retrieve candidate documents. This is similar to how Google search works. In the example that you see here, the query auth would return both OAuth and author as matches or results. However, it would not match the related statements like SAML or OpenID Connect, which we know are also common authentication or authorization methods. So keyword search is great for giving Cody access to the entire code base and giving Cody the ability to generate context from it. But keyword search lacks the ability to infer meaning and similarity. And so that's where embeddings come in. So keyword search matches documents based on how many words they share with the query. However, the most relevant document may just have a few words in common. So we want to look at the meaning of words in context, not just in their textual form. To do this, we use a technique called text embedding. Embeddings encode words and sentences as numeric vectors, and then these vector representations are designed to capture the linguistic content of text and can be used to measure the similarity between a query and a document based on meaning. And this is especially relevant for code because code often uses abbreviations or library names to refer to the same concept by different names. So for example, using embeddings, that query that we ran for auth would match both OAuth, OpenID Connect, and even SAML, which are all common authentication or authorization methods. And it wouldn't return things like authorship, since that's not commonly abbreviated as auth. So embeddings are the preferred method for fetching context. Compared to keyword search, embedding search uses all of the code in the specified repositories, not just code within a local workspace. It matches code based on the meaning of the query and not just the exact terms. And so when embeddings are generated for a repository, it gives Cody the ability to generate much more relevant and accurate context. And it gives Cody the ability to really understand the code base and the user's query more deeply. For more on the code graph and how Cody generates context using both search and embeddings, check out the Cody context white paper, which explains each feature in detail. We'll link this down in the description of this video. We'll also talk more about how to create embeddings for Cody later on in this video. Before we dive into creating embeddings, let's first talk about Cody's data security and privacy. Cody relies on Sourcegraph, which is SOC 2 compliant. So when Cody is enabled and used, there are three components that interact with sensitive data or code. The first one is the Cody client, so the editor plugin that's being used or using Cody in the web UI on your Sourcegraph instance. The Sourcegraph instance itself that has your code base indexed on it, as well as the large language model or the LLM that we send Cody's context window to for processing. So on the Sourcegraph instance, all the Cody clients that are connected to it respect the repository permissions that have been configured on that instance. So that means that Cody never uses any information from unauthorized repositories to respond to a user. Additionally, a user's Cody client accesses the Sourcegraph instance with an access token, which the user generates on that Sourcegraph web application within their user settings. Admins can view, audit, and even revoke access tokens at any time. The Sourcegraph instance can also record audit logs of user interactions with Cody if these have been enabled within site configuration. These audit logs may reside on the Sourcegraph instance or may be sent to a custom log destination if you want to integrate your instance with external log forwarders. On the large language model or LLM side of things, Cody uses Anthropic's Claude API as our preferred LLM. And so Cody will send requests from that Sourcegraph instance that it's connected to Anthropic's API. To reduce the risk of data leakage and compliance concerns, Cody Enterprise offers the following features that we've negotiated with Anthropic. The first is zero data retention. So both inputs or prompts and outputs or the results are not retained or stored by Anthropic. Those prompts are only processed for the duration of time needed to return the results to the user and then are permanently removed afterwards. There's also no other data sharing. So those inputs and outputs are not shared with any third parties for any reason. Anthropic has also agreed to do no data training based on the data shared from Cody. So those inputs and outputs are not used to customize or train Anthropic's models. Additionally, no PII or personally identifying information is sent from Cody to Anthropic in the request headers or metadata about the end user. Now, one thing to note is that this applies when using Cody Gateway and when connected to Anthropic's Claude API. Cody does offer the ability to leverage other LLM APIs like OpenAI or a self-hosted API-compatible LLM. When using one of those LLM providers that are not via Cody Gateway and connected to Anthropic, we are currently unable to offer any data security guarantees. With that in mind, let's go over how Cody works and what's going on in the data flow and architecture. First, a user has a query. So that could be a question or a prompt or asking Cody to generate some code, whatever it may be. That query is then sent to the code retrieval stage. And so this is where it connects to Sourcegraph and a search and code intelligence operation is performed to retrieve relevant code snippets that relate to the user's question. And of course, during this process, strict permissions are enforced to ensure that only code that the user has access to or read permission to is retrieved. That's then packaged into a context window, which is then sent as a prompt to the large language model. That prompt receives a context for the LLM to generate a meaningful response. And then that response is processed by the LLM and sent back to the user. This process ensures that Cody can provide helpful answers to your questions, while also respecting data privacy and security by not training on or retaining any code. Before you can start using Cody, it first must be enabled on your Sourcegraph instance. If you are using a Sourcegraph cloud instance, Cody is a managed service and you don't need to enable it manually. If it isn't currently enabled for some reason, reach out to your Sourcegraph account manager and they can get it turned on for you. Cloud is the primary deployment model for using Cody. However, self-hosted Sourcegraph instances can also be used with Cody in specific circumstances. If you are interested in using Cody and you're on a self-hosted Sourcegraph instance, be sure to speak with your Sourcegraph account manager and they can help get you access. Once you've worked with your Sourcegraph account team to get access to Cody, head on back over to the site admin page on your Sourcegraph instance and go to site configuration. Once you're in site configuration, just add a new field for Cody.enabled and set it to true. Then click save and Cody will be enabled on your instance. After it's enabled, you'll then need to configure the LLM provider that you want Cody to use. We recommend using Sourcegraph's Cody Gateway, which is used by default once Cody is enabled and turned on by your Sourcegraph account team. But you can also connect to the LLM provider of your choice directly using your own keys. We'll talk more about Gateway and the various LLM providers that Cody supports in the next section. Sourcegraph's Cody Gateway is the default method for Cody to communicate with external providers for both completions and embeddings. Gateway is the fastest and easiest way to start with Cody, as the embeddings and completion models and API keys are already configured for you. For embeddings, Gateway uses OpenAI's embedding service by default, and for completions, and that's for both chat and code completions, it uses Anthropic's Claude 2 model. Cody Gateway is enabled by default once Cody is enabled on your instance, and no other configuration is required by you to use it. Gateway also supports the use of any OpenAI LLM model if you prefer to use those in favor of Anthropic for completions. To change your default model in Cody Gateway, reach out to your Sourcegraph account team and they can help you get that set up. Cody also supports configuring a connection to a third-party LLM provider directly using your own API keys instead of Cody Gateway. This method supports the use of Anthropic, OpenAI, Azure OpenAI, and Anthropic Claude on AWS Bedrock. And across all of these providers, they can be configured for either completions, embeddings, or both. To configure the use of a third-party provider, update the completions and embeddings provider sections in your site configuration, as seen in these examples here. And feel free to reference Cody's documentation at docs.sourcegraph.com for further info on how to do this. Admins also have control over which Sourcegraph users can have access to Cody. To control which users have access to Cody, first set the Cody restrict users feature flag setting to true in your site configuration, and then go to the feature flag section, create a new feature flag, name it Cody, and set the type to Boolean. Leave the value at false and click on create flag. From here, you can add users that you do not want to have access to Cody. To add the users, click on add override and then select the users or select an organization ID to restrict access to Cody for the users within that organization. Once they're added to the feature flag, users matching that criteria will not be able to use Cody on your Sourcegraph instance. As we mentioned earlier, the creation of embeddings involves splitting the codebase into searchable chunks and sending them to an external service for embedding. The final embedding index is then stored within a managed object storage service on your Sourcegraph instance. Embeddings must be enabled for each individual repository that you want Cody to have context on, and embeddings are automatically enabled once Cody is enabled. However, embeddings will not be generated for any repo until an admin configures them, and so there are two ways to do this. Embeddings policies are the recommended way to configure embeddings on your Sourcegraph instance. Policies define which repositories to create embeddings for and ensure they automatically stay up to date. To create a new policy, first navigate to the site admin page on your Sourcegraph instance, and then go to the embeddings policies section under Cody. From here, simply click on Create New Global Policy, give this policy a name, and then add a repository pattern. And then create a pattern to match against the repository or group of repositories that you want to create embeddings for. In this case, I'll just do our Sourcegraph org on GitHub, which is returning the 5 repositories that you see here. So an embeddings index will be created and automatically stay up to date for each of the repositories matching this pattern. And then I'll just simply click on Create Policy to save it, and then that'll kick off the embeddings jobs and those indexes will start running. One thing to note is that we recommend only creating embeddings for the repositories that are actively developed or relied upon, since creating embeddings for all of your repositories can consume significant resources and doesn't necessarily provide Cody with helpful context. One other thing is that embeddings, when they're created via an embeddings policy, they're automatically updated with every new commit by default. Additionally, a 24-hour time interval must pass between 2 embeddings. So for example, if a repository is scheduled for embedding at 10 a.m. and then a new commit happens at 11 a.m., the next embedding will be scheduled at the earliest for 10 a.m. the next day. Admins can also create one-off embeddings jobs. Typically, this is used to test Cody on a specific repository and isn't recommended for production use, as the embeddings index will not stay up to date like it would if it was created via an embeddings policy. To create a one-time embeddings job, go to the embeddings jobs page under the Cody section in Site Admin. Click on the search box at the top of the screen and enter the repository you want to create an embeddings job for. And then click on Schedule Embedding. This will then add that repository to the embeddings jobs queue, and it will create an embeddings index for that repository at that revision. But just remember, if you do want to keep these embeddings up to date as your code and as your repositories change, be sure to create a policy to do that. By default, the embeddings that are created are stored in the managed object storage service that comes bundled with a Sourcegraph deployment. No additional configuration is needed to use this option. Optionally, you can select to have embeddings stored on the managed object storage service of your choice, and we have documentation available for configuring storage with both S3 and GCS buckets. Additionally, there are a number of other configuration options that can be used with embeddings. These are set within site configuration and include things like filtering files from embeddings, setting the minimum interval between incremental updates, and disabling incremental updates altogether. Full details on all of these settings can be found in the Cody docs. There are a couple of different methods for accessing Cody. The Sourcegraph web UI, as well as editor plugins that bring Cody's functionality directly into your IDE. Cody in the web UI is available by default once Cody is enabled on a Sourcegraph instance. The Cody in the web UI interface can be accessed via the dedicated chat window when viewing repositories, as well as when viewing files within Sourcegraph. In this chat interface, you can ask Cody questions about your code and have a conversation with Cody, all while leveraging that context that we talked about earlier from your code base. Additionally, Cody can also do things like run commands on selected snippets of code, so you can have Cody explain functions, generate new code like tests or doc strings, or even transpile code to translate it between different languages. In addition to the web UI, Cody also has dedicated plugins available for VS Code, the JetBrains IDE suite, as well as NeoVim. These plugins integrate directly within those IDEs and provide Cody's auto-completion, chat, and commands functionality directly within your editor. To start using these plugins, simply install them from their marketplaces like the VS Code Marketplace or the JetBrains Marketplace, and follow the prompts within the plugin to sign into your Sourcegraph instance and begin using Cody within your editor. So to recap, Cody leverages Sourcegraph's code graph to generate context. This code graph currently consists of a keyword search across the code base and the use of an embeddings index to help Cody understand the relevant code. This is then bundled up into a context window, which is sent to an LLM provider for processing, and that output is returned to the user. In the future, this code graph will continue to grow and will include additional data sources for Cody to generate context from. Additionally, security and data privacy are central to how Cody operates, and Sourcegraph has agreements with Anthropic that provide zero model training and zero data retention on Cody's inputs and outputs. This approach allows Cody to develop much deeper context and understanding about a code base and provides users with more accurate and relevant chat responses, code generation, and auto-completions. If you want more info or want to follow along on Cody's progress, feel free to check out cody.dev. And for additional documentation and resources on using and configuring Cody, check out our docs at docs.sourcegraph.com.